All right, chapter 3, section 5, day 2. We're still working with this intercept form of a quadratic equation, meaning that we're going to have this factored version of the polynomial that we've been dealing with in sections 1 through 3. Just reminding you, sections 1 through 3, we dealt with like an ax squared plus bx plus c, basically a polynomial sentence. Now in chapter 2, we learned how to factor that kind of polynomial. Namely, in that case, a quadratic, we would use either X method or just asking us to solve that riddle. But essentially, we're able to rework a quadratic into this factored form that we call intercept form. And it's given this name because these factors, these parentheses, will ultimately give us what are called x-intercepts, where it's going to cross the x-axis graphically. And that's valuable because, again, in order to graph a U-shape, a parabola, I need 3 coordinate points. If I have a parabola, if I'm able to identify the most critical point, this vertex, and then a point on either leg of the U, then I can get my U-shape locked in. And by having 2 of these coordinate points, I'm able to get both sides of that U-shape. And using the axis of symmetry, which will chop that in half, I can use that axis of symmetry to locate the vertex. So it gives some very valuable information here. Okay. And in yesterday's example, we did work through graphing one of those, but today we're going to move on to these next 2 examples, which will be basically asked to do the same thing, which the punchline is that we're going to be asked to factor both of these quadratic equations. So the first thing to point out is that these are both definitely quadratics for both these examples, because in both of them I have this x squared element. That means I'm going to get the shape of a parabola, a U shape. All right. Now, the other thing to point out is that both of these are in that polynomial sentence kind of form, what we dealt with really in sections 1 through 3. This one specifically we dealt with in section 2, this one in section 3. Just based on the number of terms there and stuff. But let's read into the questions and interpret what they're asking. So in this first example that we're going to be doing today, we're given this quadratic function. We know it's going to be a U shape. And we're asked to rewrite this quadratic function in intercept form. Okay, which means we want to take this and rework it into what you see up here at the very top, what we were given in the previous example from yesterday. Basically, I want these parentheses. I want to factor it. So my first task with this first equation is to take this given polynomial sentence and factor it so that it's going to look more like this. Okay. And before we do that, I also want to talk about what we're going to be doing here in the second example. In this one, we're going to be asked to find the zeros of the function. Find the zeros of the function. Now, this term zeros refers to the x-intercepts. Right? Literally, when we talk about a zero of a function, and literally any function, whether or not it's a quadratic, when we talk about the zeros of a function, we're literally talking about where does it cross the x-axis. So using, again, this example from before, we're talking about where does it cross the x-axis, this left-right axis. All right. And so when I'm looking for those zeros, it's very useful to rework it into intercept form, because intercept form will literally give me the zeros of the function. Right. And so essentially, we're asked to do the same thing here. Now, we could go through graphing this, and then we could visually identify where those zeros are, those x-intercepts. But again, reworking this into intercept form will be a little bit more convenient for us. It'll pull out those values exactly. So essentially, in both of these examples, we're just going to be factoring these given polynomials. And just as a secondary question here on this first example, we had to identify the vertex, and I'll go through that in a bit. So let's jump to the whiteboard. See what we're going to get. So in the first example, we are given this equation. H of x, which is just the name of the function, is equal to 2x squared minus 8. All right. Now, the first thing we were asked to do here is to rewrite this in intercept form, which again, essentially means we're going to factor this. So now we're going to go back to our chapter 2 strategies. So in order to factor any polynomial, I go through a step-by-step process. The very first thing I'm going to look for is a GCF. Now, to remind you what GCF stands for, greatest common factor. Basically, I'm looking, is there anything in common with all the terms in this polynomial? There are only 2 terms in this polynomial, and they both share a 2 in common. Right? 2 can go into 2, and 2 can go into 8. This term has an x squared. There is no x here, so the 2 is the only thing in common. So when I factor out the 2, all right, so let's rewrite this. So I'm still going to have h of x, right? Nothing's changing with that actual function. We're actually not changing anything about the function other than we're just factoring it. And so when I divide out this 2, which is the technique we learned in chapter 2, when I divide out this 2, what I'm going to be left over with, in this case, I divide 2 out of this, I get x squared. And when I divide 2 out of this term, I get -4. All right, so always look for your greatest common factor first. In this case, both terms had a 2 in common. Now I'm going to look at what I have left over. Can this factor further? Well, the next step in our factoring process from chapter 2 was to check for special products. Okay, basically, is there a difference of squares? In this case, there's 2 terms. Is there a difference of squares? Yes, I can take the square root of both these terms. So difference of squares will be my next strategy. Difference of squares, right? So it's still h of x, right? Nothing's changed the function. I'm actually not changing anything of the values or anything. I'm just rearranging it. And so this 2, this greatest common factor, is still out in front. But now when I break up this other factor, this x squared minus 4, I'm going to end up with 2 binomials. And so the process we learned here was that anytime I have a difference of squares, I'm going to end up with this sum and difference combination, where I take the square root of this first term, right? Square root of x squared is going to give me just x. And the square root of this 4 is going to give me 2. So here is my fully factored version. And so the answer to the first part of this question, where it says rewrite in intercept form, there's my intercept form right there. We see our 2 parentheses, our 2 factors. This term right here will end up being the a of my quadratic, which will determine the shape of the parabola. I'm not asked to graph here, but that will be useful for that. But these will end up being my zeros, my x-intercepts. And in intercept form, that will give me 2 coordinate points that I can plot if I were asked to graph. Now, the second part of this question did ask me to identify the vertex. Well, I can use these values to identify the vertex. Right? So first off, identifying what my zeros are, what my x-intercepts are. In this case, I'll do the shortcut version, which is to say I'll just take the opposite sign of both these terms. So in this case, my x-intercepts will be at -2 and at +2. Right? Just taking the opposite sign here. Now, the other way you could do is I could take each of these parentheses, set each one equal to 0, and then solve for x. Well, in that case, I would just subtract 2 to each side. In this case, I'd add 2 to each side, which is why we get these values. So my x-intercepts are these, right? So in this case, I would go left 2 on the x-axis. There'd be a point there. This one, I'd go right 2 on the x-axis. There'd be one there. So I have 2 x-intercepts pulled from those factors. Well, based on these x-intercepts, here's how I'd go about solving for my vertex. I need to first figure out where my axis of symmetry is, what will split these 2 values in half. Now, it may be more obvious here, but let's go ahead and go through the math, and that we were given this formula. It's called the midpoint formula. Basically, I'm going to add my 2 x-intercepts, my 2 zeros together, in this case, a -2 and a +2. I'm going to add them together and divide by 2. This is finding the average value. It'll find what's exactly in the middle of these 2 values. Again, you might be able to do this in your head, but again, just for the sake of it, we'll work through the solution. So -2 plus 2 is going to give me 0, and that 0 is going to be divided by 2. And when I divide 0 by 2, I get 0. All right, well, what does that 0 mean? That ends up being the axis of symmetry. Whatever this parabola, this quadratic, would look like when I graph it, 0, when x is 0, that means left to right 0, that's going to chop my parabola in half. That's the axis of symmetry, but I was asked to identify the vertex. So what do I do with that 0? I'm basically doing an XY table thing. I'm going to take that 0, plug it back into my equation. To remind you, my equation, I'll go ahead and use the this one up here, right? So h of that 0, I'll put that in, I'll replace the x in a second. It's going to be 2 times, then it was x plus 2, and then it was x minus 2. But I'm replacing x with that 0. And so when I plug 0 in for x, 0 plus 2 gives me 2. 0 minus 2 gives me -2, right? And then I have 2 multiplied out in front right here. right? What we're ultimately doing in this case is we are finding out the y value to my coordinate. And so doing the math at this point, just the arithmetic essentially, right? So 2 times 2 gives me 4. That 4 times a negative 2 gives me 8. Negative 8, forgive me. And what we've created is a coordinate point. That negative 8 paired up with that 0 gives me my vertex. 0 again was the axis of symmetry. When I plug that value into my equation, right? When I plugged it back into the equation, it spat out negative 8. We've created a coordinate point. The vertex of this is going to be at 0, negative 8. That is the answer to that part of the problem. Okay, so the second example will be much quicker because we're not asked to do quite as much. The vertex, finding the vertex from that problem was probably the longest step in that problem because we had to, plug it back into the equation, all of that. But our next problem, we're simply asked to find the zeros of the following function. So we're given this function, a quadratic. We're given negative 2x squared minus 10x minus 12. Right? This will definitely produce a parabola because of that x squared. But we're asked to find the zeros here. That's a fancy way of saying factor it. Factor it, put it in intercept form, and then you'll be able to identify the zeros, the x-intercepts of this quadratic. So what I'm going to have to do here is I'm going to have to factor this problem. Again, it goes back to the same thing. First thing we're going to look for, greatest common factor, GCF. Right? And so in this case, there are no x's in common with everything because that's missing an x, but 2 can go into each of these problems. I'm going to go ahead and pull out a negative 2 from each of these. So if I pull negative 2 out, let's see what's left over. Negative 2 out of this first term, I'm going to be left over with just x squared. When I pull negative 2 out of this guy by division, I'm going to get positive 5x. And when I pull negative 2 out of this guy, I'm going to get plus 6. And if I were to redistribute that negative 2 throughout, I should get right back where I started. Well, now that I've pulled out that negative 2, that greatest common factor, I need to check to see if this will factor further. Well, in our chapter 2, we learned that these trinomials, these 3-term polynomials, I'm going to do one of 2 strategies. I'm either going to use X method or I'm going to just ask the riddle. The only way I can just skip to the riddle is if it's just x squared in front. And since it is, I can just jump to the riddle. The riddle says, what 2 things will multiply to make this value, 6, that also add together to give me positive 5? Well, there are only a few things that multiply together to give me 6. 6 and 1, and 2 and 3. Now, both 6 and 1 and 2 and 3 can combine in some way to make 5, but I have to be careful with how they do that. Now, if I were to say 6 and 1, right? 6 times 1 definitely gives me 6. I would have to have 6 minus 1 to give me 5. But if I had a minus 1, the 6 times the minus 1 would actually give me a negative 6. The fact that that's positive means that that combo won't work. A little subtle there. So the other combination I have, the other option I have is 2 and 3. 2 and 3 multiply to make 6, and 2 plus 3 do in fact add to give me 5. So that's the combination I'm going to roll with. So here, my technique was to use the riddle. Hopefully that rings a bell with what that actually means. But in this case, that negative 2 never went away. But what I'm going to create are these 2 factors from that trinomial. Now, x is at the front of both, because that x times x will get me right back to x squared. What I need to identify are these other 2 items. And again, that's the answer to the riddle. What 2 items multiply to make positive 6 that also add to make positive 5? And the answer to that riddle in this case was plus 2 and plus 3. It doesn't matter which one went where, just as long as I had both. And what we have created is an intercept form of the original polynomial. So back to what the question was asking for. It asked for the zeros, which is another way of asking for what are the x-intercepts. To answer that more directly, it's both of these values here. These represent these zeros or x-intercepts. And the long way would be to say each of the parentheses set equal to 0, using our zero product property to solve for x. Or the fast way, the shortcut way, is just take the opposite sign of both these guys. So my zeros here in this case will end up being a negative 2 and a negative 3. These will be my zeros. or x-intercepts, whichever will work. But these will end up being my zeros. All right, and that's the end of this lesson. We'll be back tomorrow to finish up section 5.